And India has achieved a milestone in its civil nuclear program with the country's most advanced atomic reactor.
Beneath India's dust, heat, and exploding demand, a strange buried metal is pulling nuclear science in a new direction. Not oil, not gas, not sunlight, thorium. And if India can finally make it work, this reactor could change how an entire nation thinks about power. The energy hunger of a rising India. India does not need a little more electricity. It needs a lot more and fast. Cities keep expanding, factories keep running deeper into the night, and digital infrastructure keeps multiplying behind the scenes. Every new layer of growth adds pressure to the same system, the grid. That is why energy in India is not just about utility bills or power plants. It is tied to industrial growth, national resilience, and long-term stability. A country building at this scale cannot rely on short-term fixes forever. It needs sources of power that can keep up for decades, not just election cycles. And that pressure is exactly what pushed India to think differently. Instead of asking only how to produce more power right now, Indian nuclear planners began asking a harder question. How do you build an energy future around the resources your country actually has? That question leads straight to thorium. Why thorium became India's nuclear obsession. For most countries, thorium is an interesting side note. For India, it became strategic. The reason is simple. India has limited domestic uranium, but it has large thorium resources. That imbalance shaped the country's nuclear thinking for decades. Suddenly, nuclear power was no longer just about copying the standard path followed elsewhere. India needed a system that could start from one fuel reality and gradually move toward another. Thorium became important not because it was trendy, but because it matched India's geology. But thorium comes with a catch. It is not a ready-made miracle fuel. It cannot just be dropped into a reactor and expected to behave like conventional fissile material. That is why India's thorium push was never really about one metal alone. It was about designing an entire long-term national pathway around it. The three-stage plan that changes everything. India's thorium story only makes sense when you see the full roadmap. This was never meant to be one reactor showing up and changing everything overnight. It is a three-stage nuclear plan, and each stage prepares the ground for the next. The first stage uses pressurized heavy water reactors running mainly on natural uranium. These reactors generate electricity, but they also do something more important for the future. They produce plutonium in spent fuel. That plutonium becomes essential for what comes next. The second stage moves into fast breeder reactors. Here, the system is no longer just making power. It is breeding more fissile material and helping create the conditions needed for the thorium pathway to become possible. This stage acts as the bridge between India's current reactor base and its long-term thorium ambitions. Only then does the third stage begin to open up. This is where thorium-based systems can operate at meaningful scale using uranium-233 in a broader thorium cycle. So the real story is not a single invention. It is a patient nuclear ladder built step by step, with thorium waiting at the far end of it. Meet the reactor. Inside India's Advanced Heavy Water Reactor. At the center of this vision sits the Advanced Heavy Water Reactor, or AHWR. This is not meant to be some magical final machine that instantly powers all of India. It is a 300 megawatt electric design created to demonstrate technologies needed for large-scale thorium utilization. That role matters. The AHWR is important, not because it finishes the mission, but because it proves whether the mission can realistically move forward. In India's thorium strategy, this reactor is a bridge between concept and system. Its design also reflects how tailored this project is. Rather than simply copying a familiar uranium reactor from abroad, the AHWR was shaped around India's own long-range goals. The machine is not trying to look futuristic for headlines. It is trying to solve a very specific national problem. How this reactor actually works. This is where the story becomes less about ambition and more about physics. Thorium does not generate power in a reactor all by itself. It needs support from fissile material to begin the cycle. That is why the AHWR design uses a carefully arranged combination of thorium-based mixed oxide fuels that include uranium-233 and plutonium. The logic is deliberate. Thorium enters the system not as a shortcut, but as part of a controlled chain. Over time, the reactor is designed to help sustain the production and use of uranium-233, which gives thorium its long-term nuclear value. That is what makes this reactor so significant. It is not just about burning fuel. It is about proving that thorium can function inside a real engineered cycle, rather than remaining a laboratory idea or a political slogan. If that cycle holds together, then thorium stops being theory and starts becoming infrastructure. The safety design that makes AHWR different. Power alone is never enough in nuclear energy. The harder question is, what happens when systems fail, heat rises, or operators lose time? That is where the AHWR tries to separate itself from older nuclear anxieties. Its design places strong emphasis on passive safety. In simple terms, that means key safety functions rely more on built-in physical behavior and less on rapid human or mechanical intervention. One major example is natural circulation, where coolant flow depends less on the kind of large active pumping systems many people associate with conventional reactor designs. The broader idea is clear. When conditions worsen, the reactor should not become instantly more dangerous, because everything depends on perfect reaction speed. The AHWR is meant to buy time, slow escalation, and stack multiple layers of protection into the design itself. That matters because any serious thorium future has to win trust, not just attention. The catch no one can ignore. Now comes the part hype usually skips. India's thorium vision is real, but it is not close to becoming an overnight national power solution. The biggest reason is structural. Thorium depends on the success of everything that comes before it. India still needs breeder progress, reprocessing capability, fuel fabrication capacity, and the wider support systems that make the third stage possible. Thorium cannot bypass that chain. It has to wait for it. That is why this story should not be framed as a near-term miracle. The challenge is not imagination. The challenge is sequence. Every delayed link in the system pushes thorium further down the timeline. So the real obstacle is not whether the reactor sounds impressive in a headline. It is whether the entire supporting ecosystem can mature in the right order. The engineers, experiments, and the long game. What makes this program fascinating is that it does not move like a media event. It moves like a relay. One generation of scientists and engineers builds part of the pathway, then hands it to the next. Reactor design, material science, reprocessing, instrumentation, and fuel cycle research all have to advance together. That is why smaller research infrastructure matters so much. Even low-power experimental facilities play a huge role because they generate the data needed to validate reactor behavior and confirm whether design assumptions actually hold up. And the wider program is still moving. India's Prototype Fast Breeder Reactor. Reaching first criticality on 6th of April 2026 matters because it shows the bridge stage is not frozen in theory. It does not mean the thorium era has arrived, but it does mean the long game is still advancing, one technical milestone at a time. So, is this really infinite energy? Not literally, and not yet. Thorium is not infinite, and India is not on the verge of flipping a switch that suddenly unlocks endless power. The honest version of this story is more grounded than the headline, but also more impressive. India is trying to build a nuclear future around its own resource base, using a plan that unfolds over decades rather than months. The AHWR is important because it represents a serious attempt to turn thorium into a working energy system. Not a fantasy, not a miracle, a system. And if that system matures, it could give India something very few nations ever achieve. A long-term nuclear path shaped around domestic strategic logic instead of imported fuel dependence. So no, this is not infinite energy. It is something harder to build and easier to believe in, a patient national effort to create power that can endure. And honestly, that may be the more powerful story. If you enjoyed this deep dive, like, share, subscribe, and stay with us for the next story hiding just beneath the surface.